Hello friends, my name is Wbbse. I was teaching you chapter variation from Ganit Prakash of class 10 West Bengal Board of Secondary Education. So in this chapter, that is chapter 13, we have completed up to question number 10. Now today I am going to start from question number 11. Question number 11 says, if A varies as B, B varies as C, let us show that A cube B cube plus B cube C cube plus C cube A cube will be directly proportional to ABC into A cube plus B cube plus C cube. So this is our question. So let us first write this information. This is given. Show that A cube B cube plus B cube C cube plus C cube A cube is directly proportional to ABC into A cube plus B cube plus C cube. So this is what we have to prove or we have to show. Now from this relation we can say and from this so these are two equations we are going to use. We know if the ratio of these two quantities is a constant, then we can say they are directly proportional to each other. Okay, so now we are going to find the ratio of these two quantities and see whether that is a constant or not. We can write this is equal to, we are putting the values of A and B in this expression. Let us do one thing. Here we can see A equal to K1B, B equal to K2C. Now we can again put this value of B in this equation. Then we get a relation between A and C. So now becomes K1 K2 into C. A equal to K1 K2 into C. Now if we put these values, then in place of A we can put K1 K2 C. And cube into, in place of B we can put K2C and a cube. So in this expression we have put the value of A and B, plus in place of B in place of A and in the denominator ABC, that is K1 K2 C into K2C into C within bracket, in place of A cube we can write in place of B we can write in place of C. So we get this expression. Now if we simplify this expression we get K1 cube K2 cube C cube K1 cube K2 cube C cube into K2 cube C cube plus now if we again simplify it we get we are taking common, we are taking k2 cube c6 c to the power 6 as common. We are taking c cube common. So we can say this thing is a constant. So we can write this thing as c. This is a constant. So we can see that the ratio of the given quantities, the ratio of these two quantities is a constant. Therefore they are in they are directly proportional to each other. Therefore so this is done. Let us now proceed to question number 12. Question number 12 says, to dig a well of x decimeter deep, one part of the total expenses varies directly with x. Okay, so we have to dig a well which is x decimeter deep, and one part of the total expenses varies directly with x and the other part varies directly with x square. Okay, if the expenses of digging wells of 100 decimeter and 200 decimeter depths are 5,000 and 12,000 respectively, let us write by calculating the expenses of digging a well of 250 centimeter depth. Okay. So the question says, let us assume the expense for digging a well is y, and it is divided in two parts, A and B. Expense for digging a well, that is y. Now they have said that A directly related to A is directly related to x, and B is directly related to x square, where x is x is the depth of the well. So one part of the expense is directly related to x and the other part is directly related to x square. So if we use this equation, this relation, and convert it into an equation, it becomes A equal to k1 into x, and if we convert this equation, this relation into an equation, it becomes B equal to k2 into x square. Therefore y is k1 into x plus k2 into x square. So this is our equation number 1. And the first condition says, if x equal to (100 dcm), y equal to 5,000. Total expense is 5,000. So if we put these two values in equation 1, we get and if we cancel two zeros from both sides, it becomes 50 equal to k1 plus k2 into 100. Again, the second condition says if x equal to 200 dcm, so let us say this is our equation 2. If x is 200 dcm, y is 12,000. And if we put these values in equation 1, we get $12,000 equal to K1 into 200 plus K2 into 200 square. That means 40,000. And if we cancel two zeros, if we cancel 200 from both sides of this equation, it becomes let us say this is equation 3. From equation, if we solve these two equations, equation 2 and 3, we can get the values of K1 and K2. So let us subtract equation 2 from equation 3. Okay. We are subtracting equation 2 from equation 3. If we subtract this equation from the first, then signs are changed, so it becomes negative, it becomes negative, and it becomes negative. So 10 equal to plus K1 and minus K1 cancel each other, and 100 into K2, or K2 equal to 1 by 10. K2 equal to 1 by 10. So equation 2 was $50 equal to K1 plus K2 into 100. So we are putting the value of K2. So K1 is 40. Now we know the values of K1 and K2. So equation 1 becomes y equal to 40 into x plus x square by 10. X equal to, so we have to find out y equal to question mark when x equal to 250 dcm. Now in this equation we are putting the value of x. So this should be the answer. The value of y is 16,250. Let us now solve question number 13. Question number 13 says volume of a cylinder is in a joint variation with square of the length of its radius of base and its height. Volume of a cylinder is in joint variation with square of length of radius of base and its height. Okay. Ratio of radii of base of two cylinders is 2:3 and the ratio of their heights is 5:4. Let us find the ratio of their volumes. Let us find the ratio of their volumes. Okay. So let us first write the given informations. Question number 13. The question says volume is directly related to r square. This is radius of base and it is directly related to height. So if we combine these two relations, we get V varies as r square h. Now if we convert it into an equation, it becomes V equal to K into r square h. Now the question says we have two cylinders and the ratio of their radii of bases is 2:3. Okay, so we have two cylinders, the ratio R1 and R2. This is the radius of first cylinder, this is the radius of second cylinder. This is 2/3 and the ratio of their heights is 5:4. So H1 by H2 is 5:4. We have to find out the ratio of their volumes. Okay, so V1 by V2 equal to, okay, using this equation we can write this is K into R1 square H1 by for first cylinder and K into R2 square H2 for second cylinder equal to, if we put the value of R1 square and R1 and R2, so we can write it this way, R1 by R2 whole square into H1 by H2. Now we are putting the value of R1 by R2, that is 2/3, H1 by H2, that is 5/4. So our answer should be 5/9, 5:9. The ratio of their volumes will be 5:9. This is our answer. Thank you friends for watching my video. If you have any question or doubt, you can leave a comment. I shall try to answer your doubts. Thank you.